if f of x is equal to modulus of x plus 1 for x less than 0, when x is equal to 0, it's equal to 0, and for x greater than 0, it is going to behave in the form of modulus of x minus 1. For what value or values of a does the limit exist? So first thing is, before we do anything with the question, we need to resolve the modulus aspect. So whenever we give any value which is, just a second, which is less than 0 to our modulus function, what does it do? It will multiply with a negative 1 and it will give us the output. So for an input of minus 1.4, it gives us an output of plus 1.4. If it's positive, then it gives us positive, the same number, right? And so the question will turn out to be, since we are talking about x less than 0, it will multiply with minus 1, and so we'll get minus x, and we have plus 1 over here. So when x is equal to 0, then we have this to be 0. For x greater than 0, it won't do anything with the x, it will just give you x itself, and we have this to be minus 1. Okay, now they're asking for what all value of a. Is this continuous? First thing first, let's consider all the values before 0. So let me talk about possible points to discuss. This is not meant for your exam, it's only meant for your understanding. Possible situation. Now we are looking at first possibility is x less than 0. Okay, so we have a definite expression for x less than 0. If this is 0, all this has an expression of minus x plus 1. So it's a polynomial expression, so it's continuous everywhere. At 0 is where there are three variations. Right? When we are approaching 0, there are two variations. And after 0, so there is a definite expression, that is plus x minus 1. So it is easy to tell that the function is continuous throughout before 0 and throughout after 0. At 0 is something that we have to check. Okay, so there will be three different cases. So we'll start off with case x less than 0. So what can you tell? For x less than 0, f of x is equal to minus x plus 1. Thus, as the function is a polynomial function, it's continuous throughout x less than 0, right? So that is the first thing. So we can have a value, anything which is less than 0. Okay, now next is your case x greater than 0, and in this case we have f of x is equal to a particular expression, and so we can write the same thing, which I'm not going to write. Thus, as the function is a polynomial function, it is continuous throughout x greater than 0. Okay, and now the third thing is, and the last thing, case x is equal to 0. So we have limit x tending to left hand limit, so that would be limit x tending to So I think it is minus x plus 1. Yeah. So when we do substitute it, what will we get? 0 plus 1, and that would be equal to 0. Now we have case for same case actually. Now the right hand limit f of x as x tends to 0 plus, this would be limit x minus 1. And so when we substitute, we have this to be 0 minus 1. So this is equal to minus 1. So it doesn't matter what is happening at the value. What we're looking at is as limit f of x tending to 0 minus is not equal to limit f of x as x tends to 0 plus. So what can we conclude? This implies limit does not exist. Agree? And finally, what can we tell? To summarize, limit f of x as x tends to a exist for all a other than 0. That's it. So if you guys write this, of course you can write it in any other way. The sentence can be in a different manner. Don't think too much about it. So this is how you have to prove it. Please understand the concept that we have a consistency before 0 and consistency after 0. Since we are looking at a polynomial expression, at 0 is what we have to examine, and when we examine, we saw that it's not continuous at that point, but everywhere else it is continuous. So we need to prove that everywhere else it is continuous by writing a simple statement, right? So this is how you have to approach.